In this video, we're going to be talking about the measure of an angle. And earlier we discussed that the measure of an angle is actually the amount of rotation from the initial side to the terminal side. So we're going to be talking about how to measure how much an angle or what an angle measures. So again, we're thinking about how much it rotates from the initial side around to the terminal side. And I already mentioned in a previous video that one way to measure angles, and probably the one that you're most familiar with, is to use degrees. And we know that a full revolution, if we went all the way around back to the initial side, that is a 360-degree revolution. And so 1 degree corresponds to 1/360th of a rotation about that vertex. And typically when you express that angle, you're going to express that measure using either the words degree or the degree symbol. Now, another measure that's used commonly within trigonometry and also within calculus is the radian measure. Okay, let me erase this off here so you can see the word. It's a radian measure. And radians, again, are used a lot in the functional approach to trigonometry. They're used a great deal in calculus because sometimes dealing with the radians is going to be much easier than dealing with the degrees. And there's a separate video that explains how the definition of a radian, but the formal definition says it's a measure of the central angle of a circle that intercepts an arc equal in length to the radius of the circle. And the full revolution, if you go from the initial side and rotate completely back around to the initial side, a full revolution is 2 pi. And hopefully you know from your previous math courses that pi is 3.14. So 2 pi is about 6.28. And typically when you're writing your measurement of an angle in radians, you're not going to have any units. We don't usually write the word radians. It's going to be just a number. It could be a decimal, or it may contain the measurement pi. So to convert from one to the other, because again, sometimes it's easier to use radians than degrees or vice versa. Sometimes it depends upon the context. Again, typically with triangles, we use degree measurements. And then with a lot of the others, we may use the radian measure. So the conversion ratio of degrees to radians, the primary one that you really need to focus on is that pi, 1 pi equals 180 degrees. And you may think, well, where does that ratio come from? So let me kind of show you. Remember, I just told you that a full revolution from the initial side to initial side is 360 degrees. And in terms of radians, that is a full revolution is 2 pi. So if I look at that relationship, that a full revolution is either 2 pi or 360 degrees, and then I divide both sides by 2, to simplify that, I get this relationship that pi equals 180 degrees. Now, if we want to go one step further, because we're thinking about radians, if I divide both sides by pi so that I have 1 radian is equal to 180 degrees divided by pi. So 1 radian is approximately 57.3 degrees. If that helps you to get a kind of a picture in your mind of the measurement of a radian. 1 radian is approximately 57.3 degrees. But again, the primary relationship that you need to remember at this point is that pi equals 180 degrees. So let's talk about and look at some examples of how to convert from degrees to radians first. So if I have an angle that measures 100 degrees, okay, I'm going to set that up as a ratio. So I have 100 degrees over 1 times, and I'm going to use that conversion ratio. But I have to think about which number goes where. I'm trying to eliminate the degrees, so I'm going to put degrees in the denominator. So I have 180 degrees corresponds to pi. So if I multiply those together, remember to multiply fractions, you multiply the numerators, multiply the denominators. So I'm going to have 100 degrees times pi over 1 times 180 degrees. And so what I notice almost immediately is now I have degrees in the numerator and degrees in the denominator. And so those will divide out, and I still have my pi units, and so I want to simplify 100 over 18. Now you might be able to do that in your head, and if you can, that's fine, but you can also use your calculator. Okay, so on your calculator, we can enter 100 divided by 180, and then I'm going to press the button that says math and choose option 1, which is fraction or frac. So it's going to give me a fraction. You want to leave it in fraction form. You do not want to convert it radians to decimals. So we would have 5/9. So we end up with 5 pi ninths. 5 pi ninths corresponds to 100 degrees. Leaving it as a fraction and in terms of pi gives you the exact value. If we converted it to a decimal, it would be an approximation, and so it's best to use the exact value. All right, so looking at the second example, we have negative 315 degrees. So again, I'm going to write that as a ratio or a fraction, negative 315 degrees to 1 times our conversion ratio. And again, I need to eliminate the degrees, so it goes in the denominator and the pi goes in the top. So I have negative 315 degrees times pi over 180 degrees. And again, I see that I have degrees in the numerator and degrees in the denominator, so they will divide out. Again, I could do it in my head, but I'm going to use my calculator. I enter negative 315 divided by 180. I want to go back to math, option 1 for fraction, and it gives me the fraction negative 7/4. So ultimately here, the exact value is going to be negative 7 pi over 4. Okay, so negative 315 degrees corresponds to negative pi fourths. Now let's look at some examples of how to go from radians to degrees. Most students are not as familiar with radians, at least initially, and so they like to actually convert back to degrees often to help them figure out the problem. Okay, so let's look at how to set this up. It's the same kind of idea. You already have a ratio or a fraction of 3 pi fourths. This time I'm trying to eliminate the pi, so I'm going to put pi in the denominator, and that corresponds to 380 degrees. So I have 3 times 3 pi times 180 degrees over 4 pi. And so immediately I notice that I have a pi in the numerator and a pi in the denominator, so they will simplify or divide out. 3 times 180, again, you might be able to do that in your head. 180 times 3 is 540. So I get 540 divided by 4. 540 degrees divided by 4, which if I do that division gives me a value of 135 degrees. So 3 pi fourths corresponds to 135 degrees. Negative 7 pi thirds. Okay, so we start over. It's a new problem. So I have negative 7 pi over 3 times, again, this time I'm trying to eliminate the pi, so it goes in the denominator, and I have 180 degrees. So I have negative 7 pi times 180 degrees all over 3 pi. So again, I notice I have a pi in the numerator and a pi in the denominator. They will divide out. Definitely want to get my calculator here, and I want to multiply negative 7 times 180, okay, which gives me negative 1260 degrees divided by 3. Okay, so then I need to do that division. So I'm going back to my calculator. So I'm going to divide by 3, which gives me negative 420. Okay, so I have negative 420 degrees. So negative 7 pi thirds corresponds to negative 420 degrees. Now notice how in that particular answer we get a negative as well as a value that's larger than a full revolution, because remember, a full revolution is 360 degrees. Sometimes working with negative angles or working with angles that are larger than a full revolution can become very awkward. It's easier if you have a positive angle or if you have one that's between 0 and 360 degrees or 0 and pi. And so we'll talk about it in a minute about how to deal with that. But first, I want to review something that hopefully you learned from your geometry days. We do classify or group angles based on their measurement in degrees or radians. Hopefully you're aware of an acute angle. An acute angle measures between 0 and 90 degrees. Or 0 and pi halves, and I've given it to you in words as well as the mathematical symbols. And that particular angle, if you were drawing it in the standard position, would lie in quadrant 1. So I'm just going to draw you an example of an acute angle here on the screen. Then you also have a right angle. A right angle measures exactly 90 degrees or pi halves. It's actually a quadrantial angle. And typically with a right angle, to indicate that it is right, and there's no doubt, you'll see a little box drawn in the corner to indicate that it is truly a right angle. Then you have an obtuse angle. An obtuse angle measures between 90 and 180 degrees, or between pi halves and pi, and it would lie in quadrant 2. And then finally, you have what's called a straight angle, and a straight angle actually looks like a horizontal line. Now, typically we would know they want it to be an angle if they show the direction of the rotation. And a straight angle measures exactly 180 degrees or pi, and again would be a quadrantial angle. Now, as I mentioned, sometimes working with those negative angles or angles that are greater than 360 degrees can be challenging and be awkward. And so one of the ways that we combat that problem is we use what are called coterminal angles. Coterminal angles are 2 or more angles with the same initial side and the same terminal side, but possibly with different rotations. For example, if we take a look at an angle that looks like this. It's in its standard position, so the vertex is on the origin, horizontal axis is the initial side, and say we rotate it around to 140 degrees. And notice I've rotated in the positive direction. But I could also name that angle as being negative 220 degrees if I rotated it in a negative direction as opposed to the positive. I do counterclockwise or clockwise, and it's actually the same angle. Okay, you would visually see the same picture and you wouldn't be able to tell the difference. We could also, if I'm going to try to sketch it here on this grid again, I could also start at that initial side, go a full revolution, and back to that same terminal side, and I would have a 500 degree angle. So a coterminal angle, if you know your English, okay, if you're familiar with words in English, co is the prefix that means with. So coterminal is it has the same, or with terminal, it has the same terminal side. And so it's an angle that has the same terminal side. And every angle has infinitely many coterminal angles because I could keep going around and around and around and making multiple revolutions. But again, we can use this concept to help us find angles that are not negative, and also to find angles that are not greater than 360 degrees. And here are the formulas that you use for doing that. You take your given angle, and then you can add and subtract 360 degrees as many times as you need, which is represented by the letter K. Or you can take the given angle and add or subtract 2 pi as many times as you need, which again is represented by K. It may also help you to draw yourself a picture of the angle so that you can get a sense of whether you need to add or subtract 360 degrees. So in this example, it says find an angle between 0 and 360 degrees that is coterminal with the given angle. And so the given angle is 700 degrees, which is, it's obviously greater than 360. Okay, but you may want to kind of get yourself a picture of what's going on here. Okay, so you can kind of get an idea. Okay, so 700 degrees, let's think about it. Okay, so we start with our standard position, initial side on the positive x-axis. We rotate one full revolution, that's 360. If I come all the way back around again, that's going to be 720. So I'm not quite okay, I'm not quite all the way around a second time. Okay, so this would be the actual 700 degree angle. Okay, and I want an angle that's between 0 and 360. So since I'm trying to make it smaller, that's kind of my clue that I maybe want to subtract. So I'm going to start out doing 700 degrees minus one revolution, which is 360 degrees. And you can get your calculator. Okay, so I would have 700 minus 360 degrees gives me an angle of 340 degrees. Okay, so an angle of 340 degrees, which is between 0 and 360. So if I'd only gone one partial revolution, I would have the angle 340 degrees. Okay, so then looking at the next one, I want to try to do negative 40 degrees. Okay, so if I think about what a negative 40 degree angle would look like initially in standard position, it's negative, so I'm going to rotate this direction. So there would be my negative 40-degree angle. Okay, but I want an angle that's positive, and I want it to be between 0 and 360 degrees. So this time I'm going to add 360 degrees. So from negative 40 degrees, I'm going to add 360 degrees. And again, you may want to get your calculator. Okay, so I would have negative 40 plus 360, and that equals 320 degrees. So my coterminal angle, if I went round positive, would be 320 degrees, which meets the criteria of being between 0 and 360. Now, you can do the same thing if you have it in terms of radians. It's a little bit trickier because you have to deal with fractions, and most students don't want to deal with fractions. So if we think about negative pi ninths, and again, if you want to try to draw a picture here, you can get a sense of, okay, where it would be. It might be a little bit tougher because you're not as familiar with radians, but let me see if I can sketch it for you. Since it's negative, okay, I know I'm rotating this way, and pi ninths is going to be somewhere along in here. So here is negative pi ninths. And so I'm trying to find the coterminal angle that's between 0 and 2 pi. So I need to take, and I need to add 2 pi, because first of all, it's negative. So to make it positive, hopefully I can add a full revolution of 2 pi. But now remember, to add fractions, you have to have that common denominator. So in terms of ninths, I would have 18 pi ninths. Think about it. 2 pizzas, 9 slices gives me 18 slices. So I have negative 1 pi plus 18 pi ninths is going to give me positive 17 pi ninths. So if I had rotated in a positive direction, I would have the angle 17 pi ninths, which is between 0 and 2 pi. Again, that may not be as obvious to you. Okay, so you may want to think about that. Okay, and then 44 pi ninths. Okay, so let's see if I can sketch you a quick graph here. 44 pi ninths. I can kind of tell that it's at least more than a full revolution. Okay, so I would have the initial side. Okay, in terms of ninths, one full revolution would be 18. A second full revolution would be 36. And I need a little bit more. I need 8 more. So that's going to give me 36. 8 ninths. I'm going to be almost, let's see, almost back around here, about a whole nother half revolution. Okay. So 44 pi ninths, I've actually made a full revolution, 2 full revolutions. Okay, so I want to think about this because remember, I'm trying to get a value between 0 and 2 pi. So again, I can start out and I can do 44 pi ninths. I'm going to subtract 2 pi. That gets rid of 1 revolution. Let's see if that's enough. Okay, but again, you got to have that common denominator. So 44 pi ninths minus 18 pi ninths. Okay, so get your calculator. 44 minus 18 gives me 26 pi ninths. That's still more than a full revolution. That's still more than 2 pi. So I'm going to subtract 2 pi again. Okay, so I do 26 pi ninths minus 18 pi ninths again, which gives me 8 pi ninths. So ultimately, my answer is 8 pi ninths. Now, what I could have done is initially I could have multiplied this 2 pi and said, okay, I want to do it 2 times, and I could have subtracted it 2 times, which would have been 44 pi over 9 minus 4 pi, or 36 pi over 9, and I still get 8 pi ninths. Okay, it's just a matter of whether you want to do it in one step or two step if you don't realize you need to subtract it 2 times. But again, we often use those coterminal angles to find a positive angle if it's negative, or to find an angle that's between 0 and 360 or degrees, or between 0 and 2 pi, one full revolution.